Awesome. All right. So today we'll be looking at scaling geospatial data with SuperAnnotate. My name is Luis Riera, and I am a machine learning solutions engineer here at SuperAnnotate. A little bit about the agenda for today. We'll begin with a geospatial data intro, talk about what it means to have geospatial data. We'll also look to account when working with geospatial data. We'll then look into the Okay, so it seems like just my computer is bugging out, but we have also on the outline some automations that we'll talk about where you can automate certain tasks on our platform to have the machine learning labeling workflow kind of more in a automatic manner here. We'll talk about how we can do quality checks with the automations within SuperAnnotate, and then also convert and upload your data directly to your cloud. We'll also dive into some tiling solution that we've developed for high resolution data. And finally, we'll finish off by explaining how we can scale teams and projects with SuperAnnotate. Just a little intro to our company. If you're not familiar with SuperAnnotate, it was co-founded by Tigran and Vahan. They're two brothers who were studying machine learning and computer vision. They were getting their PhDs, and they came up with a super pixel algorithm, which made the annotation workflow more efficient, and it allowed annotators to really scale up the amount of data that they could label. So based on that, we now have the ability to annotate, version, and manage the ground truth data for your AI systems. A little bit more about the product here. We have two main components. One is a software service where you'll be able to use our platform, which I'll show a little bit later, to label images. You can then have reviews on those annotations. We have project management and process automation, like I've been mentioning. And then part of our ML Studio, which is also the software, is the ability to curate your data, use our SDK written in Python to automate any part of your workflow. And then there's some also task prioritization that we can do for active learning. So all of this is within the software, within the platform. That's one subset of our service here. And then the next part is the ability to leverage our annotation workforce. So we can set up labelers on our platform to work on your data, to label anything that you're requiring. And then we'll be able to produce those outputs for you and just share you the final annotations. So in that sense, we're kind of an extension of your team where we can place labelers from all around the globe on your projects, and you will not have to worry about managing them or checking up on their progress. That'll be also done by us. So those are the main things here for our service. Now, in terms of geospatial data, how we can help. First off, we'll review a little bit about what geospatial data is. So it's time-based data that's related to a specific location. It can also include other types of data, not just images. So it could be census data, which could be.
Lou, could we pause for a second here? It feels like I think that the initial outline is frozen for a lot of people currently on the presentation.
Sure. Let me reshare this. Did it update to the next slide?
Much better. Thank you.
Thank you, Oscar. Okay, so yeah, geospatial data can come in various forms here. We have weather data, cell phone data, social media data can also be added into the mix. And within all this, there's different formats. So we have LiDAR, which can be point cloud information from LiDAR systems, satellite imagery, which can be very high resolution, RGB data or infrared. And then we have text data, which can be added on top of all of this to include more attribute information. It could be the name of the location, the business, the store, etc. Okay, so In terms of the applications for geospatial data, one of the more common ones is mapping. So you can visualize the area that this data describes. You can use polygons to show these locations, the sizes and boundaries, and any relationship between any points of interest on the map. So this is obviously how Google and other type of mapping companies display their data on your phone. The next is also visit attribution. So with visit attribution, you're able to use the geolocation data that outlines not only the store, but you can use the GPS information to determine when certain customers have entered a specific location and what the foot traffic is like at specific hours. So you're able to do all this analysis thanks to geospatial data. Another use case can be urban planning. So planning construction for roads to reduce traffic. That's one of the main applications here. You can definitely see which areas of the city need to have the reduction. And you can also do the opposite, where you can build important facilities such as hospitals or schools where there is already an area where there's a lot of foot traffic. So these are, like, once again, the applications that can be used for geospatial data. Network planning is another one.
Lou, sorry to disturb again. It is still frozen for a lot of people on this one. Do you want to try switch who is sharing the screen instead?
Yeah, I think it's my Zoom for some reason is going to be doing this today. Apologies. All right. Can you let me know if I click right now? Is it going back and forth or no?
No, it is still the same.
Yeah. Okay. This might be an issue for me.
Share on our end, perhaps instead, and you can let us know.
Yeah, that's a good idea. Apologies, folks, just gonna have someone else share this for me. There we go. If you could go to page 8, please. Actually, page 9. Yeah, so for network planning, we can determine the best setup for the infrastructure to determine where the hardware would be placed best for maximum area coverage of the internet. And we can also determine the maximum bandwidth limit that we can set depending on the amount of activity in an area. So in places where there's more people active, we can increase the bandwidth to have, the internet not slow down at that specific area. And where there's less people, we can reduce the bandwidth since it won't be needed. Next, please. Okay, risk assessment is also used by a lot of engineers to develop some applications here. So you can have geospatial attributes, which allows you to see how vulnerable a building is to things like destructive weather. Obviously, places that have more inclement weather will have, the ability to have their assessment change depending on how likely it is to have that. And then other important information can be added on top of the data here, which could be what kind of businesses run inside of the building, what did they sell, how the occupancy looks during different times of the day, and so on. Okay, we'll now look at additional considerations. So sometimes geospatial data can be multi-layered. You can have RGB images, and then you can also have an infrared image of that same location. So these will be multiple layers of the same area. The images can also come from different sensors, which would mean that some of them might be different resolutions, so they might not line up perfectly on top of each other. And then images might also span slightly different geographical regions. So we'll actually look at what this means in a little bit. But high resolution images sometimes cause problems because they can cause latency and lag when you're trying to label these. So in terms of the different sensors, different resolutions, one of the ways to fix this is by matching features on the images and then performing a warp. So this is something that we can also help with, as well as assess and give you some feedback of how to handle this messy data. Here is an example of different geographical regions that might be mapped by different sensors. So the top layer is a region that's larger. It's a larger portion of the area of that particular map. And then the red region is a smaller portion within that larger area, which just highlights that red outline. So in order to make these layers work, we would have to cut out just that specific portion where the images match and overlap. And that's, again, something that we can help with and make sure that everything is set up properly so that you can get the highest quality labels on your end after this. Okay. And then, like I mentioned previously, the high resolution images are very large. And when you load them into a browser and you try to move around, zoom in, zoom out, etc., that can cause lag issues. So we have a solution on our platform which can deal with this type of data. We'll review that in a little bit. I'm going to jump into multiple layers now. So when you have multiple layers, we support that in our platform. You can upload all the layers for one particular image as one item. And when we do that, we can then toggle through each layer to compare amongst the different layers that we have for different information that they'll show us. So each layer has additional information and context that can assist the labelers in labeling. So for example, in the next slide here, we have an image of an aerial image of dolphins swimming in an ocean. So you can see that it's kind of difficult to make out the shapes here. But if we go to the next slide, we'll see this is a different layer with a different frequency. And you can see some outlines a little better. And if we go to the next layer, we can see even better with an enhancement on the image. So once again, these can be layered on top of each other. We can toggle through back and forth amongst them, and then we'd be able to better know where we want to annotate specific objects that might not be visible on the RGB only images. So this is once again a feature inside of SuperAnnotate, which can help with geospatial multi-layered projects. Another feature that helps us are automations. So we can easily create an automation inside of SuperAnnotate. We can send real-time data from any of the actions that I'll show in a moment in the platform. And we can then run a Python script on some backend server that will then do some post-processing, any georeferencing that needs to be added to the data. All of that can be done automatically without having to manually trigger anything. Okay. Another part that can be done with the automations is depending on the trigger. So for example, an image can be in many statuses. So you can have an image in quality check. You can also have an image returned. An image can be completed. You can also have folders and projects in these statuses. So these will allow us to trigger these events. It'll make more sense when I show it on the platform, but essentially when you go from reviewing an image to completing an image, that can trigger something for us depending on what we would like to do. Okay, and all of this can be encapsulated into our SDK, which allows you to develop and customize your own pipelines. So these are webhooks that we can send from SuperAnnotate, post-process the data, convert it, and automatically upload it to some cloud storage. Okay, another great feature that we have for the labeled data is data curation. So we can filter, review, and make any bold changes to your data set through this feature. This feature allows you to use metadata, look at any of the information that you're interested in, for example, class type, or maybe class name, and also the date which it was annotated on. So these can allow you to reduce the amount of data that you're reviewing and also focus on specific instances of data that might be of interest for review. So like I mentioned, you can filter on a lot of metadata here. Obviously the date, maybe the annotator that has been working on this. We can also upload custom metadata to the platform, and then we can filter on that custom metadata. So if you have any additional information that adds detail to your labels, we can definitely leverage those and use them in the review process. So the tiling solution for ultra high resolution data is a tiled editor that we've developed. So this is a high resolution image of a city, of a portion of a city. And if you go to the next slide, we can see how the tiling works. So there's, in this case, 3 different levels of tiles. You can see at the top of the pyramid here, there's just one tile. So that's when you're completely zoomed out at the most zoomed out level. You'll have that one tile with a specific resolution. Once we zoom into the first level, now we see the image breaks up into 4 tiles. So these 4 tiles now each have their own higher resolution, but since they're tiled up, they won't be visible all at once. And so this allows us to reduce the latency while zooming into a portion of a high resolution image. And if we zoom into the last level here, we can see it tiles it up into 16 different tiles. And each one of these tiles is once again going to have its own higher resolution than the previous layer above it. This is kind of how Google Maps works when you zoom into an area and just that portion is rendered in high quality. And as you zoom out, the quality or the resolution of the entire map changes. So this is very useful for high-res images and reducing lag. Okay, the final portion here that I want to talk about is going to be on scaling teams and projects with SuperAnnotate. So the great part about working on this platform is that you can invite your teammates just with their email address, and you can set up as many teammates as you would like. You can have 10 teammates, 100, 500. It really, it boils down to how many people you can have collaborate with you. We can also set this up on our end. So if you don't have the labelers or the workforce to work on this project, we can provide them for you. And similarly, we would just invite them with an email address and they'll be able to collaborate, see the data, label the data, and be part of that workforce. The next portion here allows you to assign items. So assigning randomly these items to all the annotators that are part of your team. This is something that we can also take care of and automate through our SDK. So on your end, it really depends on how hands-on or hands-off you want to be in the process. If you want to leave it all up to us, we'll manage the entire team and we'll just give you updates, ask you any questions on any edge cases that come up. But if you also don't want to be part of that process, we can pretty much do it all for you as well. Okay, and the last portion here, we can further distribute permissions. So when you invite people, they'll be part of your team. And then within your team, you can create different projects. And each project can have permissions distributed differently if that's something that you would like. But we can also give the same permissions across all projects as well. Okay, so now I'll just show a quick demo here about the curation. I'm going to try to share on my end. Hopefully it's... Okay, yeah, it doesn't seem like I can share. Would you be able to share my project? Okay, great. So if we dive into the high-res project here, we have a few items. You can see the status of those items here on the right. This one is currently in progress, and the one above it is not started. So like I mentioned previously, our automations can take advantage of these. Anytime an item gets switched from one status to the next, the webhook that gets created can be used to automate a quality check, a conversion, or an upload, pretty much anything that you would like. Okay, if we dive into one of these images, we'll have our editor open up here. And so this is a really, really high resolution image. It's very large, and it might honestly not even work that well in a regular application. But due to the tiling here, you can see that right now it's the lowest resolution that it can be at. If we zoom into the image, anywhere in the image, we'll begin to see that part of the image at a higher resolution. And so only this portion that's being rendered on the window right now is the part that's in high resolution. And so that allows us to have low latency here. We can also create any type of annotation here while we've zoomed in. So we have bounding boxes, polygons, etc. I'll just draw a quick polygon here to show what that would be like. We'll click around in the area here. And when we close this, we can select a class. In this case, we'll select house. So that's how we can label certain portions here. The labeling occurs on a coordinate basis. So these are pixel coordinates that are laid down for each point. During the conversion step on the output, we'll be able to georeference these back into world coordinates for you and deliver the information in the correct format. So that's always a possibility. And that's how we handle the georeferencing. Okay. If it's possible, we can switch over to one of the other projects to show the curation part. I actually shared another project with you, Oscar. You could do that one. So I'm just opening up a project which has some more data that I can explore through. This will allow us to filter out anything that we would like. So, for example, in this data set, I'm interested in only searching up the instances that have a polygon in it. So I'll type instance type equals polygon, and I will now receive these items here. So now I can review, make sure that any of these have polygons in them, but we can also filter this down a little bit further. We can add to the query here. So if we click on the search bar, we can say and metadata, last action, timestamp is greater than, and we'll select the date. We'll just maybe put it last week. And if we run this, now we can see these are the items that have a polygon and have been annotated within the last week. So in this way, you can filter out your data, make sure that you're only checking the most up-to-date or recent data that's been labeled, and things that have already been completed in the past or been reviewed. You won't have to worry about reviewing those anymore. So this is the Explore tool. We can also look instance through instance. So we're right now looking at it through an image level. But if we switch to instance view, we'll now be looking and going through each bounding box or polygon or key point, etc. We can also check out different attributes, for example. So if you want to check the class name, you're able to also filter, should be on bottom, I think. Okay, so yeah, so this is one way. And then the bulk action feature, which will allow us to select items from this result. So if we select a few items, now on the bottom, we can select all of them, approve and disapprove. And these will apply across all those instances that have been selected at once. Okay, so you don't have to do things one by one. You can definitely have bulk actions on the platform. And once again, these actions, which can trigger webhooks, can help automate the review process, can help automate the conversion and upload process. So your pipelines can be pretty much fully automated after they've been labeled and completed on our platform. Great. Thank you so much. This is the end of the demo for the curation and automation here. We'll now jump into the Q&A section if anybody has any questions. Thank you for your time. Okay, so I've got a question come in here. It's asking if we already have geospatial coordinates of points, can we add them to SuperAnnotate? Yes, we definitely can. There's a way to convert from geospatial to pixel points. We'll upload those to the platform, and when we're ready to resend or reconvert the data, we'll just convert back to geospatial. So yeah, we can definitely have those geospatial coordinates already integrated into the platform. Of course. Okay, another question is coming in. How does SuperAnnotate handle the storage and security of geospatial data on its platform? That's a great question. So the great thing about using SuperAnnotate for geospatial data is that your data can remain where it lives. So if you have it in an AWS S3 bucket, your data can stay there. What we'll do is we'll just grab a secure URL link, and we'll use that to read the data and render it onto the browser. So the data is never actually leaving your cloud. We're just going to be able to read and render it into the browser. Okay, another question coming in asks, in which formats can I export annotated images? That's a great question. We have our own SuperAnnotate format, which is a JSON file with very easy, just four keys there. We can also export it into Cocoa, and there's various other common formats like Pascal VOC, YOLO that we support on the output. If there's any custom formats that you require, we can also look into writing a conversion script so that anytime the output gets delivered to you, you'll have it in your format. Okay, next question asks, how can machine learning engineers use SuperAnnotate's platform to integrate with their existing workflows and tools? It's a great question as well. So machine learning engineers can leverage our SDK, which uses Python, and yeah, you can use it to pretty much integrate into any workflow and tool set that you're currently using. Any part of the uploading of the data can be automated with the SDK, the creation of classes, switching of the statuses of items. So pretty much all the things that you saw in the UI today can be automated in some way or another through the SDK. You can also use the SDK to gather analytics and then perform your own analysis on the data that we provide. So they're asking, can we use SuperAnnotate in some healthcare applications? For sure, absolutely. If there's any application that requires computer vision in terms of either object detection, image segmentation, for example, I could give you a concrete example would be if you're in an operating room and there's a camera above you, where are the specific tools that need to be handed over to the doctor? So a computer vision algorithm would be able to identify where the scalpel is, where any of the other tools are, and make its decisions based on that algorithm. So that's one specific example I can think of right now. Okay, it says we've seen a new tool on your platform, the Magic Polygon. It works very good on our data. Can you explain how the Magic Polygon tools work and how they can be used to annotate complex geospatial data? Okay, so to the Magic Polygon question, it's a machine learning algorithm that's going to select a region of interest. It'll then perform some type of image processing. And then based on, that processing, it can figure out where there's specific contours, changes in contrast, which usually help delineate where there's the edge of an object. So that's how it kind of does its object detection. It's pretty good, and what you're able to do after is actually adjust those points or edit, add, delete, and make the annotation as tight as possible. So yeah, you can leverage that to make your workflow quicker. And then you can have one person working with the Magic Polygon tool. I could show it if my browser was collaborating. Would you be able to share the tool for me, Oscar? And while we do that, there's another question that asks, how can you support satellite data spanning multiple years? And that's a great question as well. One of the abilities on SuperAnnotate is the ability to copy over any of the labels that you've already drawn on one image onto the next. So if there's satellite images from 2016, then 2017, then 2018, we can take all the labels from 2015 and just copy them over to the next year, make adjustments on that year, and then copy it over into the next year, and so on. So that allows us to work with data for multiple years and to be able to have a consistent area on parts that are not changing. Okay. I think we're just going to show the Magic Polygon tool now. But if there's any other questions, I'd be happy to answer them in the meantime. Okay, so here's an image of a football match. We're going to choose the Magic Polygon tool here. And if we scribble around this player here, you can see that the scribble is very basic, but now the Magic Polygon tool will automatically segment the entire person here. So as you saw, it was just a very basic scribble, nothing too complex. And the resulting segmentation here is pretty good. So this is the Magic Polygon tool, and similarly, it can be used to annotate your geospatial satellite images. You can make adjustments if there's any portion that's been missed. And yeah, this can also be used to annotate, cars, roads, bushes, trees, etc. Awesome. Well, I'd like to thank everyone that attended. I appreciate your time and attention. If there's any other questions, please feel free to email either myself, Louis@superannotate.com, or our support team as well, which might be able to point you in the direction if you need to talk to anyone else. It should be support@superannotate.com. Thank you once again, and I hope you have a great day.